Hello guys, and thank you for watching this video lecture. Today we are going to learn about Python decorators. Python decorators are used to modify or extend the behavior of functions or methods without changing their actual code. Decorators are implemented as higher order functions that take another function as input and return a new function with added functionality. We can use decorators in several cases like logging, access control, memorization, and enforcing coding standards. Decorators are essentially functions that wrap other functions. How? By adding some functionalities before or after the wrapped function runs. In Python, functions are first-class citizens, meaning functions can be passed as arguments, functions can be returned from other functions, as well as functions can be assigned to variables. Functions that take other functions as arguments or return them are called as higher order functions. And also, there is a type of function that are known as closure, a function that remembers the value in the enclosing scope even when the outer function has finished executing. All these discussed topics here are used by the decorators in order to provide a clean way to add functionality to existing code. So once again, a decorator is a function that takes another function as an argument, adds some functionality to it, and returns a new function. We use @ symbol to apply a decorator to a function. Let's write a basic decorator that prints a message before and after a function runs. So first, we define the decorator function that takes a function as an argument. So we name it as decorator, and it receives a function as an argument, right? Then here we define wrapper. So here we define the inner wrapper function that adds extra behavior. So for example, here print this is a message before the function is called, right? Then here we call the original function, right? And then we print this message is after the function is called. And finally, we return the wrapper. So let's run this one. Okay, it's okay. Now we apply the decorator to a function, right? So @ decorator, then def my function, and then we print this is the function being called, right? So let's run this one as well. It's fine. Next, here we're going to call the decorator function. Here, my function. So when I run this one, you can see here the result. This is a message before the function is called here. Then inside this function, we have this is a function being called, this one. Then this one will be printed. This message is after the function is called. This decorator is the decorator function that takes this f, the function to be decorator, as an argument. Then wrapper is an inner function that adds behavior before and after this function f. And this @ decorator, this syntax is equivalent to the, like for example, we say function 1 is equal to decorator, and we pass the function to the decorator. Functions often takes arguments, so decorator need to handle those arguments. The wrapper function can use star args or star kw args to accept any number of positional and keyword arguments. So in here, I'm going to try one decorator that logs the argument passed to a function. All right, so def, and I'm going to call this function as log arguments. And here we're going to receive a function, right? So this is a Docker string decorator to log the arguments passed to a function. Then here, we define a wrapper to accept any positional or keyword arguments. What is positional arguments? Positional arguments are passed to a function in the correct order based on the function's parameter list. On the other side, we have keyword arguments. They are passed using the parameter name explicitly, so the arguments could be specified in any order, right? Then here we can print that, for example, let me change this one. So for example, in here, so calling, and in here, function name with arguments, args, keyword arguments as kw args, right? So in here, we call the function with its arguments. Here we can print a function name, return these results. And finally, we return the wrapper function, right? So it's correct. So let's run this one. It's fine. Then here, I need to apply the decorator to some function that we're gonna define later. So we call this decorator, and then we can define this function. For example, this function takes two arguments a and b and sum up them together and return, right? So let's run this one. Okay, this one is fine. Then we need to call the decorator function. It means we call the decorator function with some arguments, right? So result is equal to, for example, add 5 and 3, right? And finally, we will print the result that is this one. So the result is 8 here. So now calling with the arguments of 5 and 3 and keyword arguments nothing. So here we printed these arguments and the result is 8. The wrapper function here accepts these star args and star kw args to handle any argument passed to this add function, right? It performs several tasks, including log the arguments, calls the original function, logs the result, and finally return it, right? When a decorator wraps a function, the original function's metadata, like its name or docstring, is replaced by the wrapper's metadata. However, we can preserve metadata of a function. How? Using a module that is a functool. We have an imperator like functools.wraps from the functools module that is used to preserve the original function's metadata. Let's see how to preserve metadata using functool. So we need to import from functools, we need to import wraps. We imported wraps from functools, and our objective is to preserve function metadata. Right? Then here we define the decorator function. For example, my decorator, and it will receive a function. Then here wraps func, this use wraps to preserve the metadata of the original function. We define a wrapper to accept any argument. Then in here we printed a message before calling the function, like for example, before the function call. Then here result is we call the original function with its arguments. Then here we can print here after the function call, and finally we can return the results, right? So in here we can return the results and then return the wrapper function. So let's run this one first, this one. It's okay. Then this one, it's fine. Now I need to apply the decorator to a function, right? So here, my decorator, and for example, def say hello. This is a function say hello by the user and print hello name, right? So let's run this one. It's fine. Next here, I need to call the decorator function. So print, then here say underline hello, and here, for example, John. Then here print if, then function name, say hello dot name. This print the function's name, the name of the function, and also we print the docstring, right? So you can see here before the function call hello John, after the function calls, and then none here, then say hello, then this function say hello to the user, right? This is the docstring. This decorator is used to ensure that this say hello function retains its original name and also docstring as its attributes rather than inheriting those from the wrapper. Sometimes you need a decorator to accept its own parameters. This requires an additional layer of nesting, that is a decorator factory that returns the actual decorator. So here, we're gonna try a decorator that repeats a function's execution a specified number of times, right? So we already imported wraps from the functool. So here we're gonna define def and then repeat n times, right? This one that we define here, this is the decorator factory that takes a parameter n. Then in here, we go for decorator, and this one is going to receive a function. This is the actual decorator that takes the function as its argument, right? And then here, we wrap the function. It means we want to preserve metadata of the original function. And then in here, def wrappers, args, wwkw So in here, we define a wrapper to accept any arguments. And in here, in these for loops, this underscore, it means we don't care about the I or the counter, doesn't matter. We want to loop n times to repeat the function execution. We call the original function. So func, args, and kw args, then return none. This one should be here. Return none and return wrapper and return decorator. So let's run this one. It's okay. Next, we apply the decorator with parameter n is equal to 3, and then def greet name, then print hello name. Then in here, def, for example, say something, right? Message, and we print the message. We define a function here that takes a message, right? This message will come later. And then here we print the message and we return the message. All right, this one is fine. Now we call the decorator function, right? Say something hello world. And when run this one, you can see hello world is 3 times repeated. Repeat n, this is the decorator factory that takes a parameter n and returns the decorator. The decorator here is the actual decorator that wraps the function, and this repeat 3, this means we are going to execute the say something function 3 times. A common use case for Decorator is profiling code performance by measuring execution time. Now, I'm going to try a Decorator that measures and prints execution time of a function. For that one, we need to import time. So this is a module that we use it for measuring execution time. And already we imported the wraps from functool. It's fine. So let's run this one. It's okay. Now we define a timer function which receive a func. So this is our decorator function. Then in here, wraps function, and then here we define the wrapper to accept any argument. So def wrapper and args and key arg. Then here we record the start time using this one time.current time. Then the result we call the original function, and then we printed the end time. Then we print that this function executed in this much time in seconds. We return the result, and also we return the wrapper. So that's all. It's fine. Now here we apply the decorator to a function, right? For example, timer, and then def a slow function. In here we get n. This function simulate a slow operation, right? And then here time dot sleep n, right? We pause execution for n seconds and we return n multiply 2 as an example. So let's run this one. It's fine. Now we call the decorator function. So result is equal to a slow function and we pass 2. It means n is equal to 2 and we print result, right? So you can see here function, a slow function executed in 2.003 seconds and result is 4. This timer decorator records the start and end time of execution using time.time, and it calculates and prints the elapsed time and then return the function result. We can apply multiple decorators in a single function. They are executed from the innermost to the outermost decorator. In order to see this feature, we are going to combine the timer and log arguments decorator. So we already imported wraps from functools and we already imported time. Then here, def timer and func. We here use the wraps func to preserve the metadata of the original data, right? Then here def wrapper, define the wrapper to accept any arguments. Then here start time, start underscore time is equal to time.time to record the start time, and result is func. We call the original function here, and then we record the end time, and then we print what happened, right? Then we return the result and return the wrapper, right? So let's run this one. That's fine. Now I'm going to define a log argument decorator. So def log underscore argument, and in here wraps func. Then we define the wraps to accept any argument. So we log the arguments with this code here. Then here result is equal to function args and kw args, and then we print result of this function and the result, and we return the result. All right, and also we return the wrap. That's all. So let's run this one. It's fine. Now it's the time to apply the timer decorator. So add timer, right? And then we apply the log argument decorator, the innermost, right? So log underscore arguments. Then we define compute sum, and here we get n, and then we return sum of range n. All right. Now we call the decorator function. So result is equal to compute sum like 1 million, right? And then we print the result, right? So let's see. So argument from compute sum is 1 million, then result of compute is this one, and function took time of 0.0067 seconds to execute this one, and this is the result. This decorator is applied first since it is closest to the function and it logs the argument and result. Then the timer decorator is applied after this one, measuring the execution time. The order of decorators matter as it affects the sequence of added behavior. Now I'm going to write a decorator that logs function calls, including timestamp, arguments, and results to a file for persisting logging. And this is normally useful for debugging and monitoring. So for this example, we need time, we need functool, and also we need logging. We need to configure logging to write to a file. So logging dot basic config, and then here, and for example, in here, we call the file name is equal to, for example, app underscore log dot log, and then level is logging info, format is okay, and message is okay. This is the kind of setup logging to a file with timestamp format. Next, we define the decorator function def log to file func, and then here we use wraps in order to preserve the metadata of the original function. Then def wrappers accept any arguments, and then in here start time is equal to time current time. Then here we use a try block to handle potential exception. So result is equal to, we call the original function, and also here logging.info function executed successfully. This is for log successfully execution, and then we return result. Then in here we catch any exception. We go for logging error. So logging dot error, that if we saw any error, we will log the error, and then we raise. This raise is for re-raise the execution. And finally here, this is to execute regardless of success or failure. So regardless of success or failure, we're gonna print end time is equal to time. And also we log the information here to log the execute time. In here, we return the wrapper, and that's all. It's okay. Here we need to apply this decorator. And in here, for example, def divide a and b, we return just a divided by b, right? Then we test the decorator function. Try print divide 10 by 2, for example, or print divide 10 by 0. And then in here, we catch division by 0, except 0 division as e. And then here we print this error. So let's try this one. You can see here 5 and an error occurred for this 10 by 0. Okay, so we generated one log, right? Log 5. Fine. Now let's check the app log. You can see here, this is our app log. So you can see all are logged here. Whatever we have tried are logged here. The last example here is the class-based decorators. Decorators can also be implemented as classes by defining call method. Let's try a decorator to count how many times a function is called. Class, and we call it as call counter, right? Then the underscore underscore init. This is the initialization with the function to decorator, self and func. We need to preserve the metadata of the original function. So wraps, func, and self, right? And also we initialize a counter for function called self.count is equal to 0, right? Then we have another function here that call function. So here we define a method called when the function is invoked, and self, then args and kw args, then self count plus equal to 1, increment the call counter, and also we print that, okay, this self name has been called this many times, self dot underscore wrapped underscore args and kw arg. Here we call the original function. So let's try this one. It's fine. Then here we apply the class-based decorator. So call counter. We define a function like multiply like a and b, and we return a multiply b. Then we call the decorator function multiple times. So print multiply 2 by 3, and for example, print 4 and 5, right? From functools, import wraps. Okay, then here, it's okay. Then this one, it's okay. Then this one, okay. You can see here, function multiply call 1 times 6, function multiply call 2 times 20, right? Every time it records. The class of call counter here stores the function and a counter. This call method here is invoked when the decorator function is called, and then increment the counter and calling the original function. And this wraps func and set. This ensures the class preserve the function's metadata. Okay, that's all for today. Decorators are widely used in Python for several tasks like logging, authentication, authorizing, timing, profiling, caching, validation, etc. So when creating decorators, always we use functools.wraps to preserve the original function's metadata, such as the name, docstring, and annotations. And in this way, we prevent the loss of critical information that could affect the debugging or introspection. So in order to make sure that decorators are flexible and can support any function signature, we use args and kwrts in the decorators wrapper function to properly capture and pass through positional and keyword arguments to the decorator function. When chaining multiple decorators on a function, we should care about their order of application, because the execution sequence, like starting from the closest decorator to the function and moving outward, can significantly impact the overall behavior and outcome. You should take care that decorators do not unintentionally alter the decorator function's behavior or state, such as modifying global variables or introducing unexpected changes in order to maintain function's intended functionality. And the last but not least, we should verify that decorators work correctly across various function types, including those with different arguments patterns or return values. How? By testing them independently to ensure reliability and compatibility in diverse scenarios. Thank you very much for your attention, and please feel free to ask me your questions by leaving a comment below this video lecture. Thank you, and see you in the next lecture.